Alright, welcome to our review. Let's go ahead and get started here. So we are starting with the finance section. We've got a couple multiple choice questions. The first one, we're borrowing $90,000 to buy a house, and it's a 30-year mortgage, and we want to know approximately how much will your payments total over the 30 years. So your general rule of thumb here for a 30-year mortgage is that the loan amount is going to be 2 to 3 times the payment. The total of payments is going to be 2 to 3 times the loan amount. So 2 to 3 times the loan. And it's a $90,000 house. 2 times 90 would be 180. 3 times 90 would be 270. So actually 270 would be if your interest rate was higher. 180 would be with interest rates where they are about at about today's. So for us, we're going to say approximately 2 times your loan amount. For a 15-year, it would be 1 to 1.5 times the loan amount. So if you bought a $90,000 house on a 15-year mortgage at today's rates, you would pay back the 90 plus another approximately 90,000. No, wait. That's for your 30-year. We want about, I think, 1.5 here. You'd be paying about 1.5 times back. So you'd pay back the 90,000 and then approximately another 45 to 90,000. Today's rates are pretty low, so you might get away with just another $45,000, be 135,000. But looking at these answers here, $90,000, you know that that's too small, because you're going to pay back 90,000, or your loan amount's 90,000. If you pay back just 90, you haven't paid any interest. And then here you're 2 times the loan amount. Here you're 3 times the loan amount. So, and we saw that you pay back 2 to 3 times the loan amount. Here you're way over. You're more than 4 times the loan amount, about 4.5 times the loan amount. So that one is just way too high. And then here there's no interest. Okay, and so I would make it in the right range so that there's one obvious answer if you're using your general rule of thumb. And the next one here, we're actually using a formula. So again, you're choosing your formula and you're writing your formula. Don't forget to write the formulas down. And this one we don't have to show any work, because I did it as a multiple choice. So here we've got a goal to save $5,000 in 5 years, and it's going to be a down payment on a house. We're going to earn 7.5% APR, and then what monthly payment? Okay, so monthly, so that means it's going to be regular savings, and the monthly payment is going to be P. So you're using a P equals formula. So if we switch over to our formulas here, we've got single deposit, we've got regular savings, and then we've got loan payments. This is a regular savings, and it's asking what monthly payment. So that's this formula here. So let me just take that guy and we'll select him out. I'll just copy it back. And let's just put him off to the side here a little bit. Okay. So we've got a goal to save 5,000, so that's going to be our future value. And it's going to be in 5 years, and it's monthly payments. So our N here is going to be 5 years times 12 months per year, which is 60. And then we need R, and our R is going to be the APR 0.075, and we're dividing by 12 because it's a monthly loan. And then let's see, we've got future value, we've got R, we've got N, so we're all set to do our plugins. So this will be $5,000 times your 0.075 divided by 12. And we are dividing by 1 plus 0.075 divided by 12. That gets a 60 power. And then we subtract 1. And if you do the calculator work here, you should get 68.94. And you should double check that. Alright, next up here we've got a mortgage on a house, $75,000 mortgage for 30 years. And it's at 8% APR, and we're told that the normal payment's $550. We're going to make payments of $700 a month. How long? The keyword. How long is it going to take to pay off that loan? And then how much will you save? So, well, let's do the how long first. So if we go back to our formulas here, it's a loan. So we're in loan payments right here. And it's asking how long, so that's going to be the log formula. Alright, so let's grab that guy and bring him over here. So we know it's going to be how long. And let's go ahead and write down our variables. So we need PV, that's your present value, the loan amount. So that's the 75,000. So PV is 75,000. And P, that's the payment that you're going to make, the bigger payment, the 700. Because if you just make the payment of the 550.32, you're going to end up, remember N is the number of months here because we're doing monthly payments. You're just going to end up with 360 months, which is 30 years. So we want to use the larger payment of 700. And we should end up with less than 30 years. So PV, P, we need R. So it's monthly, so our M is 12. And then R is going to be our APR, which is the 8%, and then divide by 12. And 0.08 divided by 12 is repeating. It's 0.006 repeating, so we'll just leave that one like that. So let's do our plugin. So negative log, and 1 minus our PV, 75,000, times our R, 0.08, divided by 12. And then we are dividing by P 700. And that closes up our log. And then we're dividing by log of 1 plus R on the bottom. So that's 1 plus 0.08 divided by 12. And if you do the calculator work here, be careful. Remember, you want to get this quantity first and then subtract from 1. So if you're doing it all in one shot, you want to enter some extra parentheses in there. I would work from the inside out myself, do the 75,000 times 0.08 divided by 12, and then divide by 700. And then use the answer key or store that and subtract it from 1. So if you do that, then on the inside of the log, you'll get negative log, and on the inside, you should get 0.285714. And then this inside is 1.006 repeating. And the log of 0.285714 is negative, and then this other negative will make it positive. And if you divide out here, you will get approximately 188.5. And you should key that in and make sure that you get the same answer. And I didn't ask how long in years and months, so this is just going to be months, 188.5 months. How much are you going to save? Well, remember the way that you determine how you saved is you take your old total of payments, N times P, and you subtract your new total of payments. You could do interest using the 550, this lower payment over the longer period of time, and then subtract interest with the higher payment, the 700. But when you use that interest formula, if you subtract those two, your interest is NP minus PV. The two PVs subtract out when you do the old interest minus the new interest. So really, you just want to do the N times P. That's easier. So what we would have done is we would have done 360 payments. That's our original N. And they would have been 550 times 32. So that's this original payment. But instead, we did 188.5 payments. So almost cut our time in half. And if you want to, you can round that up to 189. Either way is fine for me. And we did the higher payments of 700. And if you do the calculator work here, here you get 198,115. Here you get 131,950. And if you subtract them off, you get a difference of 66, 165, and 20 cents. So we saved $66,000. Now granted, that's a high interest rate by today's standards. So, you know, at 4%, which is about where rates are now, you'd save approximately half this as much, but it's still not chump change. All right, now we're graduating. We're starting to save for an IRA, so we're saving $150 per month. That's regular savings. We got an APR here, 9%, and the employer matches the contribution. So that means that $350 a month is going to go in. You put in $150, they put in $150. How much are you going to have if you retire in 35 years? So how much will you have? That's a future value. So we want to look for the future value formula. So you go back here, regular savings here, and they're asking how much will you have. That's his first formula, future value. So just grab that guy and bring him over. All right, so a payment here, your payment, P, is going to be, because it's matching, 2 times 150, or 300 a month. Our N, this is going to be 35 years. So it's 35 years times 12 months per year. And that is 420. And then we need an R. And your R, your monthly interest rate is going to be the 9%, 0.09 as a decimal, divide by 12. And that one works out nice. That's actually 0.0075. Now we do our plugins. So payment out in front, 300 times 1 plus R. So that'll be 1 plus our 0.0075, and that gets an n power, which is 420, so 420 power, and then subtract 1, and then we're dividing by r, which is our 0.0075. Okay, and we get this quotient here, and then we'll multiply by the 300. So 1.0075, do your 420 power, caret 420, subtract 1, and then divide by 0.0075. So if you do that for this inside here, you should double check on your calculator, you get 2941.78, 2941.7844. You've still got that in your calculator, then times 300. And you will get 882,535. And 34 cents. Or something pretty close, depending on what the accuracy of your calculator is. So here, notice we had $300 a month is generating almost $1 million of savings over 35 years. If it was over 40 years, $300 a month would generate about $1 million of savings. So for you guys, remember you're shooting for 2 to 3 million. So that would be between 600 and 900 per month that you would have to put away. Which would be doable if you had matching, and if you didn't have matching, if you had 2 incomes, it probably should still be reasonable. And then how much interest will you earn? And the interest formula, if we go back here for regular savings, is your future value minus your total payments. Okay, so our interest here is our future value minus NP. So that's going to be the 882, 535, 34. And we are subtracting off 420 payments of $300 each. And if you do this multiplication and subtract from the 882, you get 756, 535, 34. So notice that almost all of that 800,000 interest. So that's that compound interest working for you over a long period of time. Okay, next up we're doing some graph theory to decide whether or not we've got an edge cycle here. And remember, the condition for edge cycle here is that you need 0 or 2 odd vertices. Remember, the odd vertices are ones that have an odd number of edges that are connected up to them. So if it does have an edge cycle, find it. If not, add edges to make it an edge cycle and then find it. So we look at this graph and I see an odd vertex here of order 3. So box that one. And here's another one of order 3. So let's box that one. And here's another one down here of order 3. Box that one. And then here's another one of order 3. I'm going to box that one in. So those are my odd vertices. This is order 2, 2, 2, 2, and 2. So then what you want to do is you want to add edges joining pairs of odd vertices. So there's a couple, there's several different ways you could do this. But one thing you could do is you could join these 2 odd vertices, and then you could join these 2. And then once we do that, now we've got 0 odds. So before we had 4 odds. So we joined 2 pairs. And now we've got 0 odd vertices. So now we can pick any place we want for our start and end. Remember, for a cycle, the start and end are the same place. So for example, so let's just mark this start equals end. And let's try and think about how we might go around this thing. So let's see here. If we went around the outer edges here to here, we couldn't finish up. But then we could go around the inside here and then come back to here and then finish up. So I'm thinking 1, 2, 3, 4, and then we can't finish up, so let's now go around the inside here. So 5, 6, 7, 8, take that inside edge for 9, up 10, and out here 11, and now we can finish up. So 12 on the left and 13 on the bottom. So, and you might want to try and find another way to do that. There should be several. Alright, now we're looking for odd vertices over here. So this middle vertex is degree 4. Let's see, 1, 2, 3, 4, degree 4 there, 4 there, 2, 3, 4 here. And yeah, everything is degree 4. Okay, so these are all even, so 0 odds. So that one does have an edge cycle. We can start and end any place we want. Why don't we do it down here? So let's mark that as start equals end, because it's a cycle. And let's think about this. If we go around the outside edges here, then let's see here. We would need to do the outside, and then we've got to get these inside edges and then these loops around there. So let's see. If I went around the outside, then went up, over, took this loop around, in, up, and then the last loop. Yeah, that'll do it. So let's do 1, 2, 3, and 4, back to the start, and then I'll go up 5, to the right 6, up over the top 7, takes me down to here, and I'll go in 8, up 9, and then down around this side here, the left side, for 10. And that's certainly not the only way to do it. And then remember, if it's an edge path that we're looking for, that we need exactly 2 odds. Exactly 2 odd vertices. And one of those will be the start and the other will be the end. Okay, next we're trying to find vertex cycles. So instead of hitting every edge once, we hit every vertex once. And we want to use this Dirac's theorem. Remember, that's that 3-part theorem. It's got 3 conditions to check. Number 1, are there greater than 3 vertices? And we count 1, 2, 3, 4, 5, 6, 7. And 7 is greater than 3 vertices. Secondly, is it connected? And it's all one connected piece. So it's connected. So both of those check out. And then the third condition is each vertex adjacent to at least half the others? So is each vertex V adjacent or connected to half of the others. So that would be 7 halves is equal to 3.5, which you're going to round up to 4. So 4 others. And well, let's see here. Well, this vertex is not. 1, 2, 3. Okay, so let's call that vertex A. Okay, it's not. It's only connected to 3 others. So no, A is not. You only have to find one exception. The one in the middle is connected to 4 others. This is connected to 4. This has got degree 4, this one and this one, but those two ends, neither one of those. They both have degree 3. So we're not guaranteed a cycle. Okay, so it does not satisfy the theorem. So we're saying determine whether the following graph satisfies the theorem. No, it doesn't, because the third condition fails. Okay, so it does not satisfy the theorem. Doesn't satisfy the hypothesis of the theorem. But it might still have a vertex cycle. So remember, the theorem's a guarantee. If all 3 of these are yes, it guarantees there is a vertex cycle. If one of them fails, then maybe you've got a vertex cycle, maybe not. So let's check it out and see here. We might still have one. So let's see, if I come up here and then I back up and I go across and come down around the bottom, I think that gets them. So let's do start and an end there on the right hand side. No, let's start and end at A. Okay, so let's let this be our start and end. And so what I was saying is, if you come across and then go up here, come to the center, go the rest of the way across, and then come back across the top, you've got your cycle. So here's 1, come back on 2, to the right on 3, 4, and 5. Then up to the top 6, and back to A on 7. So there's our cycle. Didn't use every edge, but we did hit every vertex. Okay, so yes, there is a vertex cycle. So always, still try to find a vertex cycle. So those were some key ideas from the graph theory chapter. Edge cycles and vertex cycles. Okay, now we're to statistics. We got an electronics factory. We sample some telephone answering machines from a lot or a pallet, and we take and test them for defects. We want to know population, sample, characteristic, and inferences. So the population is going to be the bigger group that things are taken from. So you're going to test 15 from each lot, or each large group of these things. So the population is either going to be, you could think of it as being the lot, or all of the machines at the factory, all the answering machines at the factory. Depends on how you interpret. The sample is the 15 machines that you took out. That's the smaller group. And the characteristic that we're looking at, we're testing them for defects. Okay, so defects. And what are some possible inferences that you could base on the results of this? Actually, this is not a poll, it's this sample. Well, remember the idea of inferential statistics is that you gather information about a sample and you generalize your conclusions to the population. So one inference could be if, for example, if there are very few defects in the sample, then that could indicate that there are few defects in all of the machines at the factory. So there are few defects in the lot that it was sampled from, or in all machines at the factory. So in other words, in the population. Whatever your population is, whatever you chose for population. So you're generalizing from sample to population. So that's really important. Or you could say if there were a lot of defects in the sample, then there may be a lot of defects in the lot or in everything that comes off the assembly line at that factory. Then something else we did in the statistics chapter was organize data, picture it, graph it. So here we want to do a grouped relative. Relative, remember, means percent. So it's group data, we're going to put it in groupings, and we're doing a frequency histogram. So this is going to be, the vertical is going to be your percent. That's relative frequency. If it wasn't relative, then the vertical would just be your frequency. And then the horizontal is going to be weights in Mrs. Fordham's 5th grade class. So we want to group these things, and we want, generally, remember, you want 5 to 15 groups. And we got 1, 2, 3, 4, 5, 6 times 3, 18 pieces of data. Let's see, I see a 105 here. I think that's my high. Yeah, there's 103. So 105 is my high. And then, let's see, I see a 62 there. Looks like 58 is my low. So what if I did 50s, 60s, 70s, 80s, 90s, and 100s? I think that would work. So let's make the chart, that's the frequency table, and then the histogram is, or the frequency distribution, and the histogram is the graph of that. So let's look at the class, or the grouping, which is going to be their weight class. And then next, let's list the frequency. And then after that, we'll list the relative frequency, the percent. So we've got, if we start with the hundreds and go down, so 100 to, let's say 109, and then 90 to 99. And I'm ending in 9, so each one of these have the same structure. 80 to 89. Since our weights are in whole pounds, we can just end at 89. 70 to 79. 60 to 69. And then the low is 58. So 50 to 59. And then down along the bottom here, let's put a total. Alright, so the number that were between 100 and 109, we got 1, 2, looks like just 2. 90 to 99, 1, 2, 3, 3 in there. 80 to 89, 1, 2, 3. 70 to 79 pounds, 1, 2, 3, 4, 5. 60 to 69 pounds, 1, 2, 3, 4. And then that just leaves our 1 then 50 to 59. So that's a 1. And if you total these up, there are 18 total, and that agrees with our 3 columns of 6. And now to do our frequency, you take each one of these relative frequency and you divide it by 18. So 2 divided by 18 is 0.11. 3 divided by 18 is 0.17. If you round to 2 decimal places. And then keep going here. Another 3 divided by 18, so that's 0.17. 5 divided by 18 is about 0.28. You just plug these in the calculator. 4 divided by 18 is about 0.22. And 1 divided by 18 is about 0.06. And if you add all these up, they should come close to 1. Now let's see here, 7 and 8, 15 and 15, yeah, I think these add up exactly to 1.00. And if you're close, if you're like 0.99 or 1.01, that's just round off error. And now we want to make our histogram. So on our vertical is going to be %. On our horizontal is going to be our weight classes here. So let's go ahead, and our lowest class starts with 50. So let's go ahead and start this horizontal at 50. And then we'll do 60, 70, 80, 90, and 100. Okay, that's weight. Remember to label your axes. And then this is going to be %, or relative frequency on the vertical. And notice our percentages run from 0.06 up to a high of about 0.28. So let me label this off in 10% increments. So 0.10, 0.20, and 0.30. And then you want to make a rectangle that between 50 and 60 it was 6%, so that's a little more than halfway to 10%. So we would be about right there. And then between 60 and 70, the 60 to 69, that was 21%. So we are about right there. And then between 70 and 79 was 28%. So 70 to 80, 28%. We're almost to 30. And then in the 80 to 89, 17%. So 17 be a little more than halfway between 10% and 20. And then in the 90 to 99, we've got that again. Same 17%. And then we've got one more. This should be 110. Because the 100 to 109, we had 11% in there. So a little over 10%, about right there. And there's your histogram. So we can tell the distribution of the data. And this distribution it's skewed just a little bit. It's not quite symmetric. It's not terrible. So remember, there's 2 parts though to the problem. There's the frequency distribution, which is the table, and then there's the histogram. Alright, mean, median, mode. So mean is just your average. Median is the middle, and when you put them in order. So don't forget to order these first, and then the mode is the most frequent. And I gave you 5 quiz scores here, so let's reorder these guys. let's see, 7 is the lowest, and then 13, and then 14, and then our 21, and then 25. So to get our mean, you're going to add all these up and then divide by 5. And if you add them up, here your x bar is you add all these up, so 25, 35, 45, 46, 50, 60, 70, 80. So 80, and you divide by 5. So that's 16. Remember, our symbol for that's x bar. And then the median, the middle value, is right there, 14. And then there is no mode because there's no repeated. So that's C. 16 is our mean, 14 our mode, and no median. Sample standard deviation of our quiz scores. Remember, the standard deviation tells the variation of the scores around the mean. So here, remember, you set up a table, you list your individual data values xi, and list your x bar, and then xi minus x bar, that's the deviation from the mean, and then your last column, xi minus x bar squared. And that's the squared deviation, so the unsigned deviation. Want everything to be positive. So our values, let's go ahead and list them, smallest to largest, or largest to smallest, whichever. Why don't we go from the top down? 25, 21, 14, 13, and 7. And we'll put some sum or total rows down here. So these total up to 80. Our x bar here is the 16 that we figured up here. So it's 16 all the way down. The deviation, you just subtract these two columns. So 25 minus 16 is 9. 21 minus 16 is 5. 14 minus 16, negative 2. 13 minus 16, negative 3. And 7 minus 16, negative 9. And then these will add up to 80. Your deviation column, that should always add up to 0. So here we've got like a negative 12 and 2. It's a negative 14, and positive 9 and 5 is positive 14. So that's a double check that you did your deviations right. And then you just square all these numbers to get this column. So 9 times 9, 81. 5 squared is 25. Negative 2 times negative 2, positive 4. Negative 3 squared, positive 9. And negative 9 squared, positive 81. And then add these up, and you get a total of 200. And that's the sum of the squares of the deviations. So remember that your variance is, the formula for variance is the sum of the xi minus x bar squares, and then you divide by n minus 1, one less than the number of numbers. So this top number, that's the 200. And then you divide by, there's 1, 2, 3, 4, 5 numbers here. So n is the number of numbers. So n equals 5. So this is 5 minus 1, 4. So 200 divided by 4, 50. Remember, that's your variance. And then the standard deviation is the square root of that. So square root of 50, which is approximately 7.07. So it's measuring the spread of the data. Okay, now here we've got a national average GPA is 2.89, standard deviation is 0.27, your GPA is 3.24. What's the z-score? Okay, so remember that z-score is the difference between the data value and the mean, x minus x bar, and you divide by standard deviation. So our individual data value, that's your 3.24. Okay, the national average, okay, an average is an x bar value, So the 2.89, that's your X bar, and standard deviation there, this is your S. So we are going to take X is 3.24 and subtract off our X bar, which is 2.89, and divide by our standard deviation, which is the 0.27. And if you divide these out, you get about 1.30. And remember, what this tells you is if you draw the bell-shaped curve, standard normal curve, remember that 0 is always in the middle, and then the data is between 1, 2, 3 standard deviations to the right, and 1, 2, 3 standard deviations to the left. And this 1.3, that is about right here. Okay, so that's 1.3 standard deviations. And these are z-scores here. And the corresponding x values that go with them, well, the mean here, the national average was 2.89. That corresponds to the z equals 0. And the 1.3, that corresponds to your GPA, which is the 3.24, for example. And then remember, the kind of questions you can ask is, what percentage of the GPAs are below yours? So what's your percentile? So that's saying, what is the percentage that's to the left of that 3.24? Well, remember that you can look this up from the table. And if you need a table, I would provide it for you. So actually I have the table here. If we flip over to that, we see that the table gives us values from z equals 0 out to the right. And our z-score, remember, the tenths digit is here and then the hundredths digit is here on the column. So ours was 1.30 here. So we go down to the 1.3 row and then across to the 0.00 column. So 0.4032 right there. So that means that this area right here is 0.4032. And then this half of the data below 0, that's 50% of the data, or 0.5. So the percentile here is going to be 0.5 plus 0.4032. You add those together to get the percentage of the data, the total that's below a z-score of 1.3. So that's 0.9032. So 90.32% of the data. All right, and then that leaves us back at the voting here. So to finish up, we're given a preference table. We want to determine the plurality winner, the board account, elimination, and then pairwise competitions. So remember, plurality here is just the greatest number of first place. So this is the greatest number of firsts. So we look up here and we see A has 7 first place votes here and 3 here, so that's 10. B has 9, and then C has 6 here and 2 here, which is 8. So A has got 10 firsts, so the plurality winner is A. And then we can see that the rankings are A, and then B, and then C. Okay, although that I didn't ask you rankings here, but I could. The board account, remember the board account's the point system. We've got A, B, and C. We've only got 3 contestants here, 3 candidates. So our point values are going to go 3, 2, 1. And then this is part B. For each candidate, you're going to do the number of first place votes times 3, plus the number of second place votes times 2, plus the number of third place votes times 1 point each, and get our total. So we're going to do that for each one of the candidates A, B, and C. So I'll just make some copies of that. And this one will be for A, and for B, and for C. So we see A had 7 first place votes here and 3 more here, so 10 firsts. Second place votes, we look at the second row, and it had 9 seconds here and 6 seconds on that ballot. So 9 and 6, 15 second place votes. And then in the third place row, we see A is third place 2 times. So this is 30, and another 30 is 60, and 2, 62. For B, first place votes, right here, 9 ballots, so 9 firsts. Second place votes, right here and right here, that's 7 and 2, so 9 seconds. And then third place votes, 3 there, 6 there, so 3 and 6, 9 second, or 9 third place. So 27 and 18 and 9. So let's see, that is 27, 18, 37, 45, 54. And then for C, we have first place, 8 votes for first place, 6 and 2. In the second place row, I see C here on 3 ballots, and that's it. So 3. And then in third place, 7 times there and 9 times there, so 16. So we've got 24 votes here and 16 here, so that's 40, and 6 more, 46. So A wins the board account. Plurality with elimination. So remember, that's where you eliminate the lowest number of first places. So the lowest number of firsts were C, because it had 8, B had 9, and A had 10. So C is gone, to cross out the C. And then we rewrite our table. So now we're just going to have first and second place. And it's either A over B, or it's going to be B over A, like on that ballot. So remember, you remove C and you move the B's and A's up into first and second. So this is A first, B second, and you move the B up here, that'll be another A over B. So there's 10, and here's another one, these two will move up, first and second, and that's 16. So 16 ballots will be A over B. And then B over A is going to be 9 ballots here, and then 2 more here. So 11 there. And then number of first places, 16 for A, 11 for B. B is eliminated, so A wins. So A wins with elimination. And then just be watching here. If there's, for example, if there were no B's in the first row, if there were only A's and C's, B would be the first to be eliminated because it would have 0 first place votes. So like if the A and B were switched here, B would have no first place votes. So it would be eliminated first. And then the last one is pairwise competitions. So that's where you do the one-to-ones. So we've got A, B, and C. So there's really only 3 competitions here: A to B, A to C, and B to C, because there's only 3 candidates. So we can look at A to B, and A to C, and B to C. And remember, we're looking here, how many times is A over B in the table? So A is over B here, 7 times here, that's 3 times here, that's 10, and 6 more here, so 16. To B would be whatever is left, B over A. There's 2 times here and 9 times here, so that's 11, 16 to 11. and A wins that one-to-one contest. Between A and C, we see A is over C 7 times here, 3 more times here, that's 10, 9 more times here, that's 19, and then it's switched. So 19 times that A is over C. C is over A is going to be the remaining, which was here, 6 here, and 2 here, so 19 to 8. So the 19 wins there, so A wins that one-to-one. And then between B and C, we ignore A. B is over C 7 times here. They're switched 9 times there, so 16. Switched, switched. So that's going to be 16 to 11 again. And so B wins in that one-to-one. So A wins twice, and B wins once, and C wins 0 contests. So A is our overall winner. And then our rankings are A, B, C, which is same rankings we had in board account. And remember how you do rankings here? A wins, so it's ranked first. The next to last one eliminated, which was B, that's second. And the previous one eliminated was C, that's your third. So all of our rankings here are ABC for all 4 different voting methods. And that should put you in good shape. No Bonzoff Power Index, no Shapley-Shubik Index, but you do want to go back and look over your old exams, the answer keys, and the answer keys should be on Joule at the top of the page. At least for the first 2 exams are up there. I will check on the other and make sure those are available to you. All right, very good. I will see you at the final exam.